A team of scientists sailing along the coast of East Greenland just watched something happen in real time that usually only shows up afterward in satellite data. An entire wall of glacier ice collapsing into the ocean in a matter of seconds, right in front of their cameras. Researchers aboard the research vessel RRS Sir David Attenborough were working near Sorgenfri Glacier, deep inside a remote fjord system north of Kangerlussuaq, when a massive section of the glacier's front broke away all at once as evening set in. The section that calved stretched a full kilometer across the ice face, averaged around 100 meters thick, and totaled an estimated 18 million metric tons of ice, gone in an instant. Today, we're going to break down what actually happened in that moment, the mechanism driving events like this across Greenland right now, and why scientists studying the wider ice sheet say this single dramatic clip is really just a visible symptom of something far bigger unfolding beneath the surface. Let's start with the ice sheet itself, because the scale involved here is almost impossible to picture in ordinary terms. Greenland's ice sheet covers roughly 1.7 million square kilometers, an area larger than Mexico, and holds enough frozen freshwater that, if it melted completely, global sea levels would rise by more than 7 meters. It's currently the second largest single contributor to global sea level rise, behind only the simple thermal expansion of ocean water as the planet warms. And it has lost mass in every single year since the late 1990s, without exception, according to NOAA's long-term tracking of the ice sheet. To be clear, nobody studying this system expects that full 7 meters to materialize on any timescale relevant to anyone alive today. The concern instead centers on how much of that ice sheet's fate is being locked in right now, and how quickly the pace of loss is accelerating compared to the relatively gradual, predictable trends scientists were describing even 15 years ago. Here's what makes an event like the one witnessed near Sorgenfri Glacier worth paying attention to, even though scientists on board were quick to point out that glacier calving itself is a completely normal part of how ocean-terminating glaciers behave, especially during summer. Calving is the process by which chunks of ice break away from a glacier's leading edge where it meets the sea, and it happens constantly across Greenland's coastline as glaciers flow downhill and eventually reach open water. What made this particular event striking wasn't that calving happened, it's that scientists happened to be positioned exactly where they could witness and film such a large section letting go all at once, rather than piecing the event together afterward from satellite imagery days or weeks later, the way researchers usually have to. Sorgenfri Glacier itself sits in one of the most remote and rarely visited fjord systems on Greenland's eastern coastline, meaning direct human observation of any calving event there, let alone one of this size, caught cleanly on camera, is exceptionally rare, regardless of how the ice sheet as a whole is behaving. Think about what's actually driving the acceleration behind all of this, because the mechanism goes well beyond a glacier simply melting from warm air at the surface. Researchers studying one of West Greenland's fastest-moving glaciers, Cermak Kujalek, also known as Jakobshavn, in the Kengia Ice Fjord, published a study tracing exactly how a single event can trigger a rapid chain reaction. Sitting on top of glaciers during summer are temporary meltwater ponds called superglacial lakes, pools of water that collect in depressions on the ice surface as surface melting increases through the season. When one of these lakes suddenly drains, often through a crack that opens straight down to the glacier's base, it sends a sudden pulse of water rushing to the bottom of the ice, lubricating the boundary between ice and bedrock, and letting the glacier slide forward dramatically faster than normal. Researchers compared the resulting effect to a traffic jam suddenly clearing, a wave of accelerated flow that pushes material forward and destabilizes the glacier's leading edge. In one documented case from July of 2022, the drainage of just 2 of these superglacial lakes triggered a subglacial flood that produced 25 large calving events within a single 2-hour window at the glacier's terminus. If you're finding this breakdown useful, go ahead and hit that like button. It genuinely helps this kind of science coverage reach more people who want to understand what's actually driving these dramatic clips, rather than just watch them for shock value. That single glacier alone, Cermak Kujalek, discharges more than 50 gigatons of ice into the ocean every single year, making it one of the single fastest moving and most active ice streams anywhere in West Greenland. Jonathan Kingslake, a glaciologist involved in analyzing this research, has pointed out that the overall rate of melting across Greenland right now is running nearly 7 times faster than it was just 30 years ago, a pace that creates genuinely alarming risk for coastal communities around the world that depend on stable sea levels. That acceleration isn't confined to one glacier or one fjord. It's showing up across the entire ice sheet at once, and researchers describe these speed-up pulses as a feedback loop worth watching closely, since a glacier that flows faster tends to thin faster at its edges, which in turn makes it more vulnerable to exactly this kind of lake drainage-triggered acceleration happening again the following summer. A separate, sweeping study published this year in the journal Nature Communications, led by researchers including Joseph Bonsoms at the University of Barcelona, analyzed extreme melt events across Greenland going all the way back to 1950 and found the pattern has genuinely broken from anything in the historical record. Meltwater production has climbed from an average of roughly 12.7 gigatons per decade across the 1950 to 2023 baseline period up to 82.4 gigatons per decade since 1990, a six-fold increase. The total surface area affected by extreme melt events has been expanding by roughly 2.8 million square kilometers every decade since 1990 as well. Perhaps most tellingly, 7 of the 10 most extreme individual melt events ever recorded on the ice sheet have occurred since the year 2000, including major spikes in August of 2012, July of 2019, and July of 2021. Researchers involved in that study also point to a second compounding driver working alongside rising air temperatures. Warmer water from the Atlantic Ocean is increasingly reaching Greenland's marine, terminating glaciers from below, melting ice directly at its base, and destabilizing the glacier's structure from underneath, even in places where surface conditions might look relatively unremarkable from above. That combination of surface melt driven by warmer air and basal melt driven by warmer ocean water is exactly what researchers mean when they describe Greenland's ice loss as increasingly running on 2 separate engines simultaneously rather than one, which helps explain why the acceleration recorded over just the past few decades has so dramatically outpaced what earlier climate models originally projected. If deep Earth science coverage like this is something you want more of, subscribing means you'll catch the next update the moment researchers capture or measure something new happening across the ice sheet. To really appreciate the scale of what's accumulating year over year, it helps to step back and look at the longer-term picture rather than any single dramatic clip. A separate NASA-affiliated analysis built a striking time-lapse visualization showing that between 2010 and 2023 alone, Greenland lost roughly 563 cubic miles of ice, more than 2,300 cubic kilometers, enough to completely fill Lake Victoria, Africa's largest lake, several times over. That visualization specifically highlighted how the edges of the ice sheet, exactly the kind of marine terminating glacier fronts like Sorgenfri Glacier and Cermak Kujalik, are melting and calving away substantially faster than the comparatively stable interior of the ice sheet, which is precisely why researchers increasingly focus their most detailed monitoring efforts on these outlet glaciers rather than the ice sheet as a whole. Watching that 13-year span compressed into a matter of seconds on screen produces almost the same visceral gut punch as the Sorgenfri footage itself, except instead of 18 million tons disappearing in an instant, it works out to a sustained average of somewhere in the range of 400 million tons of ice vanishing every single day across that entire 13-year stretch, day after day, year after year, largely invisible to anyone not watching the satellite record closely. It's worth being clear about what all of this does and doesn't mean for the near future. Because responsible coverage of a dramatic clip like the Sorgenfri calving event means resisting the temptation to frame it as evidence of imminent catastrophe. A complete collapse of the Greenland ice sheet, the kind of event that would eventually unlock its full 7+ meters of potential sea level rise, would unfold over centuries under any realistic scenario, not years or even decades. Individual calving events, even genuinely massive ones like the 18 million ton collapse witnessed near Sorgenfri Glacier, are a normal and expected part of how these glaciers have always behaved during summer months. And no single event like this one should be read as proof the entire system is failing all at once. Coastal towns in Greenland itself, along with the tourism vessels and research ships that regularly operate near these active glacier fronts, factor exactly this kind of unpredictable calving into their standard safety planning, keeping a respectful distance from active ice faces precisely because a collapse of this scale can generate dangerous waves without much warning. What the science does say clearly is that the underlying trajectory has shifted into what researchers describe as a genuinely new regime, one defined by melt events that are more frequent, more widespread, and more intense than anything captured in over 70 years of historical record. Even in years with above-average snowfall, like 2025, ice discharge from calving and surface melt runoff has continued to outpace accumulation, keeping the ice sheet's overall mass firmly on a downward trend. That combination, individual dramatic events layered on top of a steadily worsening long-term average, is exactly why scientists describe this as reaching Greenland's breaking point. Not because any single glacier is about to vanish overnight, but because the ice sheet as a whole appears to be crossing into territory where its contribution to global sea levels becomes effectively locked in for generations, regardless of what emissions decisions get made from this point forward. Bringing this all together, what the crew aboard the RRS, Sir David Attenborough, actually captured near Sorgenfri Glacier was a genuinely normal glacial process, calving, playing out at a scale and in front of an audience that made it impossible to look away from. 18 million tons of ice gone in the time it takes to read the sentence is exactly the kind of moment that turns an abstract climate statistic into something visceral and undeniable. Multiply that single event by the thousands of similar collapses happening across Greenland's coastline every single melt season. Layer it on top of a six-fold increase in extreme meltwater production since 1990, and you start to understand why researchers studying this ice sheet aren't waiting for some single dramatic tipping point to sound the alarm. There's no one moment scientists are bracing for, no specific date circled on a calendar where Greenland definitively crosses a point of no return. The breaking point, in the way researchers actually use that phrase, describes something quieter and arguably more unsettling than a single collapse. It's the ongoing shift into a climate regime where events like the one caught on camera near Sorgenfri Glacier stop being rare, dramatic exceptions and start becoming an unremarkable, near-constant feature of every single Greenland summer from here forward. The alarm, by researchers' own measurements, has already been ringing for years, and every clip like this one is simply a rare chance to actually watch it happen.